Hello everyone. I am inspired by a recent occurrence to make three basic contentions regarding an arbitrary statement S. Let S be a statement. My first contention is that the statement S and the statement S or S are logically equivalent. My second contention is that the statement S and the statement S and S are logically equivalent. If I succeed in defending these two contentions, it will follow that the statement S or S and the statement S and S are logically equivalent. I shall attempt to defend my contentions by means of a truth table. In a truth table, two statements are logically equivalent if all their corresponding truth values are equal. Here is my truth table. The first column is for S. S can be true or false. The second column is also for S. If S is true, then it's true. It's the same S. So true or false. We come to the column for S or S. S or S is true if at least one of S is true. One of the constituent statements. So we have true, true, and so true. False, false, false. Next, we come to the column for S and S. S and S is true only if both of the constituents are true. So true, true, we have true. False, false, we have false. We have completed the table. Next, we inspect the columns. We compare the column for S to the column for S or S. True, true. False, false. So all the corresponding truth values are equal. And so the statement S is logically equivalent to the statement S or S. Next, we compare the column for S to the column for S and S. We have true, true, false, false. So all the corresponding truth values agree. This means that the statement S and the statement S and S are logically equivalent. It follows that the statement S or S and the statement S and S are logically equivalent. We can even see that if we compare the truth values here and there. So we have S or S being logically equivalent to S and S. Examples of application. If a student says x equals 3 or x equals 3, that implies that x equals 3. The two are logically equivalent. Consider a student applying to enter into a university who makes the following choices. First choice, electrical engineering. Second choice, electrical engineering. Third choice, electrical engineering. Fourth choice, electrical engineering. The admissions committee shall understand that the student's choices electrical engineering. Example 3. Pastor Mensa Otabil famously said, "God is good, God is good, God is good."
Well, as you know, the last couple of weeks have been quite interesting. Very interesting. And a lot has been said and a lot has been put out there. And I feel that as your pastor, I should come to church and tell you my side of what has happened, and also to equip you so that when you go out there, you will know what to say and how to respond. So I have a 3-point statement that I would make to address all the issues that have been raised in the media. The first point is God is good. And the second point is God is good. And the third point is God is good.
What do all these 3 statements imply? They imply that God is good. As we conclude, let's make some remarks. The exercise we have carried out here is purely a matter of logic. We can easily see that there are practical situations in which one would prefer to use one statement instead of the other, even though both are logically equivalent. For instance, we know that when you make a true statement once, you achieve brevity, whereas when you make the same true statement several times, you achieve emphasis and you reinforce the idea. What implications does our results here have for our solutions to quadratic equations having repeated roots? When you present a student with the quadratic equation x squared minus 6s plus 9 equals 0, our result is not saying that you should accept the answer x equals 3. Neither is it saying that you shouldn't accept. That is a separate point which we can discuss. Our result is saying that if you are prepared to accept the answer x equals 3 or x equals 3, then you must accept the answer x equals 3. Conversely, if you are prepared to accept the answer x equals 3, then you must accept the answer x equals 3 or x equals 3. I shall conclude by saying, repetitions of a true statement may be unnecessary, but they do not render the statement false.